All right, I think I'm live now. Can someone confirm if I'm live and the audio is perfectly clear? Okay, I'll read the chat till then. Looking for a previous solve C, CD क्या ही था, थर्ड में DFS बैक ट्रैकिंग थी क्या, DFS अप्लाई किया लेकिन मेरा टीली आ गया. Okay, Sage it would be give wrong sir. Tejas says hello नमन भैया. Hello, hi Tejas. और कैसा है? Okay, I think there is a little lag because I don't have any yeses. Pratik says, see directly, please. No, I can't do that. I will actually go in order only. I'll start from A and move A, B, C, and then D1, D2. D1, D2, I'll discuss actually. Like, I don't know why my solution is giving a wrong answer on test case 2, and I don't know why, like, the right answer is that way. Hey, please conduct a Q&A session. I am actually thinking of that, Rashid. I am close to 5,000 subscribers, so I'm actually thinking of doing a Q&A session. Let me know if you guys are interested, and then maybe I can do that. Sage, you was correct, I guess. Okay. Okay, cool. Today I'm going to be solving Codeforces round 801. We will be doing A, B, C and D1, D2. D1, D2 we will be discussing. It will be more like a discussion only because I myself don't know the right answer till now. Okay. Bro, miss you so much. Okay. I have been MIA for the last couple of days. I have been really busy with some work. That's why. And I don't know, like, I try to be consistent, but every time like something comes up. Although I'll have a stream tomorrow as well. I think we have a contest tomorrow, and I think I'll give that. I think it's at an actual timing. Yeah, 2:35 p.m. Okay. Can you tell me how this help is working? Help in working as front end dev. I don't know what you are trying to ask. Okay. Anyways, let's start. Let's start with the very first problem. Okay, let's do ABC first very fast, and then we'll talk, and then I can do D1 and D2. Okay, cool. In the first problem, Michael and Joe are playing a game. The game is played on a grid with n rows and n columns filled with distinct integers. We denote the square on the ith and the jth by AJ. Okay, Michael starts by saying two numbers h and w. Then Joe picks any h into w sub rectangle of the board. Okay, so basically Michael says two numbers h and w. We have two numbers, we have h and w. Okay, and then this is something that Michael does. Okay, this is something that Michael does. Then Joe takes any subrectangle of size h into w. Okay, now formally subrectangle is taken. Now finally Michael has to guess the maximum number in the subrectangle. He wins if he gets it right. Okay, because Michael doesn't know like big numbers, he wants the area of the chosen subrectangle to be as small as possible while still ensuring that he wins, not depending on Joe's choice. Okay, cool. Okay, so let's say if we didn't have this paragraph, okay, then the answer would be n into m only. Meaning that Michael can actually say n and m, Joe will choose the complete rectangle only, and then the largest number in the rectangle is also the largest number in the rectangle sub-rectangle. Okay. So whatever is the largest value in the complete grid, that is the largest value in the subrectangle as well. But we want n into w, n into m, or sorry, h into w to be minimum. Okay. What we need to do is, let's take this grid only. Okay. So if you see in this grid, what do we have? We have, let me move this. Sorry. Okay. We have 2, 12, 6, 10, 3, 15, 16, 4, 1, 13, 8, 11, 14, 7, 9 and 5. Okay, now it is obvious that we want Michael to say the largest number only. Okay, screen is not working. I think it's working. I don't think there is any issue. Okay, we want 16 to be the largest number in the subrectangle as well. To ensure that, let's look at columns. Okay, if we start any subrectangle from this point, it at least has to have a width of 2. If we start any subrectangle from this side, it at least has to have a width of 3. Similarly, if we look at rows, okay, if we start, okay, if we start, uh, sorry, 16 is not the largest number. Sorry. 41 is the largest number or what? Sorry, this is 4 and 16 is the largest number. I think I'm doing right. Answer is, yeah, cool. Okay, 16 is the largest number only. Okay, now if we go row wise, we know that it is at a distance of 2 from the start and at a distance of 3 from the bottom. Meaning, from anywhere we start in the columns, we at least need 3 columns to fit 16, and in rows, we at least need 3 columns, 3 rows. Okay, to at least have 16 in the subrectangle. So the answer is 3 into 3, which is 9. Essentially, the idea is that if this is your complete subrectangle, okay, and this is what, n into w, so this is n, n into m, this is n, this is m. Let's say this is the position, okay, where you have the largest value. So this is essentially y, this is essentially x. Okay, if this is x, this is nothing but n minus x plus 1, and this is nothing but m minus y plus 1. So what you want is maximum of either this or this, which is x comma n minus x plus 1 multiplied by maximum of, so this is what, h na, h into w, yeah, this is h, and w would be maximum of y times m minus y plus 1. Okay, so this is w, and the product of this is the answer. Okay, and that's it. So if you look at the last example as well, so the last example is this one. We have -7, we have 5, we have 2, we have 0, we have 8, and we have -3. The largest value in this is 8. So if you look at rows, h is actually going to be 2. Okay, and w is also actually going to be 2. So h into w will actually be 4, and 4 is the answer. 4 is the answer. Okay, so that is how you have to do problem A. Let me show the code as well. This is the code. Okay, cool. Okay, and I think my keyboard got disconnected. Anyways, okay. Zoom in. My code is not working. Okay, cool. Bro, editorial on C. I'll come to C. Just wait for some time. Come to C. What is happening? Why am I not able to view my solution? Let me close this link. Okay, let me open. Something weird is happening, I think. Every time I open the submission, it actually goes back to my problem page. Is this happening for someone else as well? There is some issue with Codeforces. I am not able to load myself. Start from the as well. So people are getting wrong answer on C. Really? Okay. What is happening? Is anyone else also facing some issue with Codeforces, or am I the only one? Like, is it my machine or Codeforces? That is what I'm trying. Because I'm streaming, it might be that my laptop is being flaky. Okay, I can see. Yeah, okay. I cannot. Okay, cool. Okay, so this is the code. I know the font is very small, but I am not able to zoom in for some reason. Let me try that. No, it's not working. Anyways, okay, this is the code. I'll actually do one thing. Anyways, this is the code. I'm not able to zoom in. My keyboard is not working. Really sorry about that. But yeah, nothing special. Okay, you just had to find the maximum, like the index where the maximum value is stored, and then this formula only. That's this formula. Okay, that's it. Okay, cool. Let's move to problem D. Okay, circle game. Okay, I think many people got wrong answer on problem B first. Okay, and then they like corrected it. Okay, circle game. Mike and Joe. Okay, Mike and Joe are playing a game with some stones. Specifically, they have n piles of stones of sizes A1, A2 till AN. These piles are arranged in a circle. The game goes as follows. Players take turns removing some positive number of stones from a pile in clockwise order, starting from pile 1. Formally, if a player removed stones from pile 1 on a turn, the other player removes stones from pile 1 mod n plus 1 on the next turn. Okay. So, essentially, what is happening is we have n piles. We have A1, A2, A3, so on till n piles. Okay. So, there are two players, Mike and Joe. Okay. What Mike does is he first takes the very first pile, removes some stones from A1. Okay. After that, Joe comes in and removes some stones from A2, and so on. They keep on removing stones alternatively. When they reach the end of the stone, they go back to the very first pile and go on. Okay. Essentially, this is actually a circle. We have A1, we have A2, we have A3, so on until AN. Okay. Now, and we have two players, Mike and Joe. Okay. Let's look at the test cases only. In the first test case, we have only one number, which is 37. Now, since there is only one number, 37, what Mike can do is Mike can actually remove the complete number. Now, Joe will be left with nothing to remove, and hence the answer is that Mike wins. Okay, let's look at the other case. Okay, the other case says that we have two values, 100 and 100. First, Mike has to remove some values from the very first row, and then Joe will have to remove some values from the next row, next pile. Okay, let's forget, or let's assume Mike removed all the 100 values, so this becomes 0, and Mike did this. Okay, now Joe comes in, and Joe also removes everything. Joe removes everything. Okay, so this also becomes 0. Now, when Mike comes again, he will have to remove a value from this pile because it is circular. Since there are no values in this pile, he will lose, and hence Joe will win. Okay, now if you see, at the very first instance, it looks like if n is odd, the answer is Mike. Okay, and if n is even, the answer is Joe. Why? Let's see. Let's say we had 4 values, A1, A2, A3, and A4. If we had 4 values, or let's say we had 3 values only. First look at the odd case. So we have A1, we have A2, we have A3. Okay. Mike will remove some values from this. Then Joe will remove some values from this. Then again Mike will remove some values from this. And now Joe will come again to A1. Since Mike knows that Joe will come again back to A1, he can remove all the values from A1 in the very first try. So that after that, whenever Joe comes, he will not be able to remove any value from this file and he will lose. That is the odd case. And for the even case, let's look at the even case. We have A1, A2, A3 and A4. So A1 will be removed by Mike. Then Joe will remove A2. Okay, Joe will remove A2. Okay, Mike will again remove A3 and then Joe will remove A4. Now if you see, it's again Mike's turn. So if Mike had removed every value from A1, okay, then Mike would lose and hence Joe would be the answer. But if you see, both these players are actually playing optimally. So what Mike will do is he will not remove everything because he knows that he will himself have to come back to A1. So he will remove very less values from A1, so that, because after every turn you will see, after every cycle, Mike will only remove values from A1. So we know that Mike will remove values from A1 and A3, and Joe will remove values from A2 and A4. Let's say A3 was very small. Since A3 was very small, since Mike knows that he has to remove values from A1 and A3, he will remove the least possible values from these files. And similarly, Joe will also remove the least possible values from A2 and A4. Okay. Because of that, whichever value is the least one, that person will lose. For example, let's say A3 was the smallest value. Since A3 was the smallest value, whenever Mike comes at A3, there will be a point that this A3 will be 0 and every other value will be something. And hence Mike will not be able to play and Joe will win. On the contrary, let's say if A2 had been the smallest value, then there must come there would come a point that A2 is equals to 0, Joe is not able to move, and hence Mike would win. Therefore, we first need to see all the odd values, odd index values, and then the even index values. Then we need to see whichever of these is the smallest one. Okay, like whichever index is the smallest, we need to see if that is to be handled by Mike or Joe. Whoever handles it will lose. That is it. Okay. So for odd, the answer is that if n is odd, the answer is Mike. But for even, we check index of min value. Okay. If this index is, let's say, odd. If this index is odd, that means either it is 1 or 3. Then we know that Mike will not be able to move, therefore Joe will win. Else, if it's even, we know that Joe will not be able to move and hence Mike would win. And this is the answer. Let me show my code as well. Again, I don't know. Let me see. For some reason, my keyboard is not working. I don't know why that is. Okay, anyways, let me show you the code. There's some issue with my laptop, I think. Let me open it from standing. Okay. Anyways, I forgot to ask, like, how many problems were you all able to do today? I think like A, B, and C, all the three were tricky problems. Okay, some like edge cases were there in all the problems. I don't know what is happening. Why Codeforces is loading so slow? Like, I don't know if it's Codeforces or my laptop. I don't see anyone in the chat as well. Why is that? Am I even live? Let me check. Okay, just a second. Let me just see what the issue is. Because I don't see any comments as well. Yeah, okay. I was not able to see comments for some reason. And now I am able to see them. Cool. Okay, cool. Okay, let me just go through the comments very fast. Let me open the comments on my phone. But I don't know why every time I'm streaming, some problem comes up. Okay, cool. I can see the comments now. Okay, there are so many comments. Okay. How do you see or code for help in coming? Okay, I'll take that question later. How to approach game theory problems? Just practice. Okay. I myself haven't done any specific game theory problems. Okay. Best editorial provided by you only. Thank you, Aman. I took 10 minutes to understand the problem statement of first problem. Yeah, it took me like 3-4 minutes to understand the problem statement for myself as well. Like first question problem statement was not very straightforward. Okay, tell me the contest was hard. I don't think so. ABC were easy. Okay, D1 and D2 is also easy, so I wouldn't say that like it's hard. Okay, Hrishikesh says 3, Gajala says 1, AB done, Manjot says AB, Rohan says yes, Sage Kitchen says 5. That's really nice. Okay, your screen is getting lagged. Is that true for like is it lagging now as well? Just let me know. Okay, yes sir, you are live. Your PC is throttling. Okay, Adobe के OA में CP important है. What is OA? Is it online assessment? I think. No, not really. Adobe's coding contest is pretty easy. Okay. Okay. Same comments. Same comments. Solve only one misunderstood B. Yes. Should I practice DSA more because I'm not able to solve C and D? Yes, obviously. No. That's not really the case. I'll take this question in the end. Okay. Anyways. Okay. Cool. I am able to look at the comments now. I'm looking at them from my phone. And we are done from problem A and B. Let's move to problem C now. I am not able to show my code. I think there is some issue with Codeforces or my laptop. I don't know. Okay, so let's move to problem C. The codes are pretty easy. You can just go to my like handle and number Bansal 013 is my handle, and from there you can check out my latest codes. Okay, I'll move on to problem C now. Okay. Cool. You're given a grid of n rows and m columns. We denote the square of the ith row and the jth column by ij, and the number there be aij. All the numbers are equal to 1 or minus 1. Okay. Is it possible? Okay, you start from the square 1 and can move one square down or one square to the right at the same time. At a time. In the end, you want to end up at the square nm. Okay, so we want to start from the top left corner and we want to reach the bottom right corner. Okay, cool. Now, is it possible to move in such a way so that the sum of leaves, sum of the values written in all visited cells is 0? Okay, so that is the complete problem. Essentially, what you are given is, okay, so what you are given is, okay, I'll make one grid which has an answer yes. So I'll make this grid only which is given. Okay, cool. Well, let's make this grid. So we have 1, minus 1. Let me remove the screen. 1 minus 1, again minus 1, again minus 1. Then we have minus 1, 1, 1, minus 1, 1, 1, 1, and minus 1. And the correct path for this one is take this one, then this minus 1, this one, this one, this minus 1, and this minus 1. So the sum becomes 1 minus 1 plus 1 minus, plus 1 minus 1 minus 1. And the sum is 0. Hence, there is a path possible such that the sum of all the values in the path is equal to 0. Now, we are given this grid. Okay. The constraints are pretty small, like average n and m are like, n and m individually are till 1000. Okay. So the total memory space that we are going to need is 10 to the power 6 because the grid is of n cross m. Okay. Cool. So which actually tells us that we need to find the answer in one processing also only. Like we cannot like there has to be constant number of how do I say iteration of the complete grid. Okay. Now how do we do this? Let's see what are all the possible values that we can come up with. Okay. So I'll actually take this complete grid only, this same grid. Okay. And see that the value present here is 1 only. Okay. What are all the values that can be present, like that can be the sum of all the values that we can get at this point? The only way to reach this point is from this one. So 1 and minus 1 actually gives you 0. Okay. So this is 1. I'll mark them with blue color, whichever are processed. Okay. Similarly, what are all the ways to reach this minus 1? The only way is by moving like this. and that sum would be 0 minus 1. So this is minus 1 only. Similarly, what are all the possible ways to reach this minus 1? That is summation of all these values. Okay, so it was like 1 minus 1 and minus 1. So sum of 1 minus 1 minus 1 is actually minus 1, which is here. Okay, and then minus 1, so it becomes minus 2. Similarly, what are all the paths through which we can reach this minus 1? There is only one path. If we come down from this 1, so that is 1 minus 1, the sum becomes 0. I'm writing the sums in blue color. Okay. Again, the sum till this point would be 0 plus 1 is 1. Now let's look at this point. If you see at this point, what are all the possible sums that we can get? We can either come from the left side or we can come from the top. So if you see, since both of these are 0, 0 plus 1 is 1 only, 0 plus 1 is 1 only. So the only possible value for this place is 1. Okay, cool. Again, let's look at this point. We can either come from the left side or from the top side. If we come from left side, it becomes 1 plus 1, which is 2. And if we come from the topmost side, it becomes minus 1, and we had 1 here, so that becomes 0. So we can get 0 and 2. Let's come on to this index. We can either come from the left side or from the top side. If it is minus 2 and we have minus 1 here, we can actually get a minus 3 here. Or if we actually see this 0 and we had minus 1 here, so the sum can be minus 1 as well. Or since we have 2 here and we had minus 1 here, the sum can be 1 as well. Similarly, let's look at this point now. Okay, I'm just doing this for once, and then I'll explain you like how we can see the pattern. Okay, now we have 1 here, 1 here. Since both these values are same, therefore we can either come from this side or this side, doesn't matter. The sum will be 2. 1 plus 1, 2. Okay, then if we look at this index, we can either come from this side or this side. We have 0, 0 plus 1 is 1, or we had a 2, 2 plus 1 is 3. Similarly for this 2 also, 2 plus 1 is 3. Okay, then after this, if you look at this point, we have, okay, many values. We had minus 3, we had minus 1, we had 1, then again we had 1, and then we had 3. And what we have is minus 1. So if you do minus 1 for all these values, this value becomes minus 4, minus 2, 0, or 2. So all the possible values for this point are minus 4, minus 2, 0, and 2. And if you see, since there is 0 present here, that means there is a path through which the sum can be 0. And we just have to print yes and no. Okay, so we don't have to print the complete path. Okay. Alright, now let me explain like how we can actually make use this. A simple brute force would have been if we actually do the exact same thing that I just showed you, find all the values for every index, okay, and keep doing that. But as you can see, n into m is actually till 10 to the power 6. And the maximum number of values at any point can be what? N. For now, let's say n only. So this into n will be 10 to the power 9, which is not possible. Okay, so memory wise, we cannot do that. Okay, now how do we optimize this? If you see, we're actually getting consecutive sequences. This is minus 3, 1, and 1. So that means we are actually starting from minus 3, reaching till 1 with a gap of 1. In this also, if you see, we are starting from minus 4, reaching till 2 with a gap of 1. With the gap of 2 actually, like minus 4 plus 2 is minus 2, minus 2 plus 2 is 0, 0 plus 2 is 2. So we start from minus 4 and reach till 4. Okay. Now let's take a random grid and see how to like generalize this solution. Okay. Let's say we had a grid in which we had, okay, let me mark it with like black marker only. Okay, 1, 1, 1, 1. Okay, and let's say here we had minus 1, minus 1, minus 1. Here we had 1, 1, 1, minus 1, minus 1, 1, minus 1, 1, and 1. Let's say this is one random grid that I'm taking. Let's try to do the same thing for this grid and see if this pattern is actually coming. We are at this point. Okay, the only possible value for this is 1 only. At this point, the sum, only possible sum can be 2. At this point, only possible sum can be 3. And at this point, the only possible sum can be 4. Which is if we actually go in this straight line only. Okay. Similarly, for this one, the sum can be 0. For this, the sum can be -1, and for this, the sum can be -2. These are the only possible ways. Let's come on to this point. What are all the possible values we have? We have a 0, or we have a 2, or we have a 2. When we do +1, this actually becomes 1 and 3. So all the possible values for this index are actually 1 and 3. Let's come on to this index now. We can either come from the left side or from the top side. On the left, we have 1 and 3. And on the top, we have 3, which is already present on the left. So we don't have to count that. We need to do +1. So this becomes 2 and 4. So this one becomes 2, 4. Similarly, for this one, if you see, we have two values on the left side, 2 and 4. 2 and 4. We have 4 on the top, which is already present on the left side. So we don't need to count this 4. If we do +1, this actually becomes 3, 5. This becomes 3, 5. Cool. Let's come on to this point now. Okay. We have -1 here. Okay. Let's see all the points. On the left, we have -1. On top, we have 1 and 3. If you see, this is also consecutive. We are starting from -1, reaching till 3 with a gap of +2. And we had -1 here. So if you do -1, this becomes -2, 0, and 2. So all the possible values for this are -2, 0, and 2. Okay. Now let's come on to this point. If you see, for this point, on the left we have -2, 0, and 2. And on the top we have 2 and 4. 2 is already present, 4 is also. Okay. And we need to do, I think I had a +1 here. So we need to do +1 here. So this becomes -1, 1, 3, and 5. So we have -1, 1, 3, and 5. And now if you see, like all these are consecutive only. So instead of writing this, we can actually write it as from -1 till 5 with a difference of +2. We don't need to mention +2 because for every index, it is +2 only. So we don't need to mention that. For this, we could have written like from -2 to 2. This is from 2 to 4 only. This is from 3 to 5 only. This is from 1 to 3 only. Okay. Now let's come on to this one. If you see, this says we have a range of -1 till 5, which means -1, 1, 3, and 5. And this says it has a range of 3 and 5. 3 and 5 are already present on this one. So we need to ignore this. We need to do +1 here, and this becomes 0, 2, 4, and 6. So instead of writing these 4 values, we can directly write 0 to 6. And similarly for these values. Okay, again I'll do for this one, and then I'll show you like how to merge these also. So we have -2 here, and here we have -2 to -2, which is -2, 0, and 2. We need to merge these values. Okay, then do -1. So this becomes -2 minus 1 is -3, 0 minus 1 is -1, 2 minus 1 is 1. So we have from -3 till 1. From -3 till 1. Okay. Now if you see, for this index, on the left side, we have all the values from -3 till 1. And on the top side, we have -1 till 5. So how do we combine these sets? The way to combine these sets will be, take the least value out of these two values, which is -3. And take the largest value out of this and this, which is 5. Which means we have all the values from -3 till 5 with a distance of +2. And we need to do +1 here. So if you do +1 at -3, it actually becomes -2. And if you do a +1 at 5, it becomes 6. That means for this, you will have all the values from -2 till 6 with a gap of +2. And similarly for this one as well. Now if you see, for this one, you have two sets, -2 to 6 and 0 to 6. If you merge these, this becomes -2 and 6 only. Then if you do +1 on this, this actually becomes what? -1 till 7. So we have -1 till 7. Okay. Cool. So that is how you have to do it. Now, since this is -1, at this value, what we have is -1 till 7, which means we have all the values from -1 till 7 with the gap of +2, which means we have -1, then 1, then 3, then 5, then 7. And since 0 is not present in this, therefore the answer for this would be no. Okay, that's all. You have to find all these ranges for the complete grid. In the last value, you have to see if that has a yes, and that's it. Okay, is that clear to everyone? Okay, and now during implementation, what you can do is instead of writing 1 here, you can actually write it as 1 1. You can write this as 2 comma 2. You can write this as 3 comma 3, and you can write this as 4 comma 4. This can be written as 0 comma 0. This can be written as minus 1 comma minus 1, and this can be written as minus 2 comma minus 2. That way it will be easier to implement. Let me show my code as well. I am not sure if I can do that. For some reason there is some issue. Okay, I can open the code, but I am not able to zoom. Just a sec. It is not opening the link. Okay, anyways, you can look at the code if you want from here. Okay, it's not easy to read. I know the font is very small, but I'm not able to zoom in. What you can do is you can just directly go to my handle, which is naman16013. It is right here. Okay, naman16013, and then you can look at my code. I'll just explain it though. Or do I need to explain this? I think I've explained it well enough in the board. What I'm actually doing is for the complete array, I am actually taking a pair of array, pair intent, and then an array of size n into n. Okay, and then I'm doing all these things. So first I'm scanning all the values. Okay, while scanning, I'm making a pair of x comma x, which I mentioned here. Then I am setting all the values in my first column. Then I'm setting all the values in my first row. Okay, and then for every other value which is left, I'm doing the logic. First I'm merging. This is the merging logic. Okay, first I merge the values, find the final value for that particular index, and then I replace the values. Okay, then in the end, I'm just checking if my range contains 0, if my range contains 0, and if my n plus m minus 1 percentage 2 is equals to 0. The reason I'm doing this is because this is m and this is, or like this is n. The total distance that we have to travel is n plus m minus 1. If this is odd, that means there is no way we can actually get a sum of 0. But if this is even, there is a possibility that we can get a sum of 0. So that is why I've written this case. And this also manages this condition also, because if you see, we had minus 1 till 7. Okay, if you see, we had minus 1 till 7 in this one. That means 0 is present between this. But we had all the odd values. Okay, the reason was because n plus m minus 1 was odd. Because n was 4, m was also 4. So 4 plus 4, 8 minus 1 is 7. Since this was odd, that is why we are getting all the odd values. Okay, so that is one condition that you need to add in your code. I actually missed this condition, and that is why I got a wrong answer. And then like later on I added this condition. Okay, cool. Is this clear to everyone now? Problem C. Is it clear to everyone? Okay, let's move to problem D now, I think. Let me look at the chart. Okay. Sir, Adobe के interviews में oops पे special question होते हैं. Like Adobe actually focuses a lot on oops actually, because its major code base is in C++ only, and they give a lot of importance to oops. So like just practice. Like what I did was I actually, like, I read that book. What is the name of that book? Balaguru Swami. Okay, I read that book, and that actually like helped me a lot with oops. Okay. Anyone gave Adobe MTS test here? Adobe is easy to crack if you have good understanding of oops as well as some basic logic on array and string, and rest is luck. Okay. I was working with Adobe. Okay, cool. People say NQ was accepted for C. Is that so? That is strange. That shouldn't be possible. Like, I don't think so. It is accepted. Like, Bhaiya, do you work in Adobe? Yes, I work in Adobe. Oh, but working. Okay. Why is gal always 2? Why is gap always 2? The reason for this, because we are actually adding +1 or removing minus 1. That is why the gap is 2. Bhaiya, what if we have -3 1? -3, -1, and 1 and 5, then how do we merge them? You will never have a yeah, you can actually have a condition of -3, -1, and 1 and 5. The way to merge that will be -3 till 5, because every element is either 1 or -1. Exactly. Bhaiya, how did you find out the solution for C? Did you write some random example and observe some pattern? Yes, I wrote actually this thing only, and then I observed the pattern. Okay. Like, I had in mind that there is going to be some pattern, because otherwise it won't be like, we won't be able to solve the problem. And that's why I just wrote all the cases and then saw the pattern. Okay. I have been seeing Naman from December 2021. Okay. Following, yeah, exactly. Have you solved this type of problem earlier? No, I haven't. Uh, okay. Okay, so clear. Yes. Do we use DP here? Sort of DP, you could say. Bhaiya, how did you find the solution of for C? Did you write some random? Yeah, I did. Okay. Can DFS also work for it? I don't know. No, I don't think DFS can work. That will be like brute force only. Only one doubt, how are we sure about this pattern will prevail? I think I showed the reason like why it will prevail. ऐसे दिमाग में आया ही नहीं. Have you solved this type of problem earlier? No, I haven't. How DSA or Codeforces help in companies just started to know your thought about it? Is it required in TCS, Wipro, Accenture, Deloitte, or any MNC? Are you not good for? Are they not good for working? They are good for working. And I don't think CP is much required for those companies. Okay. Uh, okay, cool. Let's move on to problem D1 and D2. Okay, I will share my approach how I did it, and like I am getting a wrong answer by the way. Okay, so don't be misguided, and then maybe we can discuss like how people are getting the right answer. Or will that be too much of a stretch for the stream? Do you want me to discuss problem D1 and D2? I myself will have to like look at the solutions. I don't know the solution. I know my solution and why it should work, but somehow it is giving me a wrong answer. Let me see if I can see the test case. See the test case which I'm getting. Okay, the test case is really large. Yeah, it is really large. Okay, okay. Utkarsh says yes. Yeah, I'm waiting for some more yes or no's. Do like the chat. Sorry, not the chat. Do like the stream, guys. I only have 42 likes, I think. Do like it. Oh, 23. Is that 23 or 42? In my phone, it's showing 23, and on my laptop, it's showing 42. What are the right number of likes? Can someone tell me? Like, that will. I am actually curious, like, why this is happening. Why is my phone showing 23 number of likes, and my laptop is showing 45 number of likes? And can someone tell me like what is the actual number of likes? I'm pretty sure like it must be okay. It's 53 now. I think my laptop is giving me the right number of likes. For some reason, my phone is not updating it. Anyways, okay. 22 on my phone. Yeah, I don't know. For some reason, in phone you're getting it wrong. Okay. 57. Why is it 57? Like it should be cross 100. I have 101 current concurrent viewers. Anyways, let's move to D1 and D2. I think people are interested in discussing. Yeah, I have a few yeses. Okay, I'll explain the problem first. Okay, because the problem itself is very tricky. Okay, cool. Let's open problem D1. There is not much difference in D1 and D2. D1 has constraints till 2000, D2 has constraints till 10 to the power 5. So essentially, like for solving D2, you have to solve it in O of n, and for D1, you can solve it in O of n square also. But the number of summations on D1 and D2 are approximately similar. So I think it's easier to think of a O of n approach than n square approach. Okay, cool. Okay, let me open D2. I don't know why this is happening. Like I am not able to open problem number D2. I am clicking on it, but it is not opening. Uh, just let me check. Also, I was close to 5,000 subscribers. How many subscribers do I have right now? 4889. I still need what? 111 subscribers. Okay. Hopefully, I'll have them by tomorrow. Okay, cool. Let me reload this. Come on, this is not opening. Is this happening for someone else as well? I am not able to open any links on Codeforces. Let me try it on a new. Yeah, it is opening in. Okay, strange. Okay, let me read out the problem statement. Okay, I did look at demoralizer's code, and I don't know like why that is working. Like, I still think like my code is correct, but it is giving me a wrong answer. Anyways, okay, let's look at the question first. The question says that I'll explain briefly explain the question. Okay, first let me make a test case. I'll make the test case, which is the third test case only. Okay, so this is the third test case. Actually, you have one node like this, one node like this, and this. This is the test case number 3. I'm not writing the node numbers, that they are not important. So what you're given is you're given a tree. This is a tree. Okay, and what you need to do is you can actually make k number of queries. How many queries? K queries. And what we mean by that is when you give k queries, there is a special node, or let's say hidden node. Let's say this is the hidden node. When you ask for k queries, every query is a node number. So let's say, let me name the node only 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say I say that I need to, I make one query. And the very first query is for node 9, which means I am going to get my distance from node 9 till node 3, because 3 is my hidden node. That distance is 1, 2, 3, 4. So I'll get 4. Now if I make another query, if I make my second query for node number 4, let's say node number 4, my distance would be 1, 2, 3. So my distance is 3. What the question is asking me is, how many minimum number of queries do I need to make such that by using these distances, I am able to find which node is hidden. Now this hidden node can be any node. It is not fixed, and you're not given which node is hidden. Okay. So yeah, that is the complete problem. It's a little vague. Let me make it more clear. Okay. So the answer for this is 2 only. Actually, if you make a query from 9 and 4, you will be able to figure out that the hidden node is 3. The reason is because when you make a query from 9, you actually see that the distance is 4. Now, how many nodes are there in this complete tree which have a distance of 4 from node 9? There are 2 nodes, node 2 and node 3. Now you need to figure out which out of these 2 nodes is the hidden node. To do that, you need to make another query from node 4. This node 4 tells me that the distance is 3. But if you see, the distance of 2 from 4 is 1, but the distance of 3 from 4 is 3. That means, that means what? Yeah, that means 3 is my hidden node. Okay, and 2 is not. Okay. Is that clear? Okay, that is why we need 2 queries. Now, let's say instead of 3, the hidden node was 5. Let's say 5 was the hidden node. Can we still figure out that 5 is the hidden node using these 2 queries only? If you see, when we make a query from 9, the distance of 9 from 5 is 1, 2, 3, 4, 5. So this distance is 5. Since this distance is 5, we will see how many nodes do we have whose distance is 5 from 9. There are 2 nodes. There are actually 3 nodes, 5, 4 and 6. So our answer could be 4, our answer could be 5 or 6. Now we make the second query, which is from 4. The distance of 5 from 4 is 2. And if you see, through this, we are able to uniquely identify, because from 4, the distance of 4, the distance of 4 from 4 is 0. The distance of 4 from 2 is 2. And the distance of 4 from 6 is what? 4. Okay. Since all these 3 distances are unique, okay, and we know our hidden node has a distance of 2, through this, we are able to figure out that the hidden node is 5. Is that clear? Like, I know it's a little difficult to understand. The statement is also not very, it is clear, but it takes a little time to understand. Okay, is the problem clear to everyone now? Okay, this is essentially the problem. What we have to do is we have to find out the minimum number of queries that we need to do, through which we can find any hidden node in the tree. Okay. All right. Is this clear to everyone? If it is, I'll explain my logic and then we can see why I'm getting a wrong answer. Okay. X Sharma says yes. I don't know why people don't make YouTube channel like their YouTube accounts with their own names. Like it's a little difficult to say your names. Harma says for C, can the two intervals be -5, 2, and 4 and 5? No, they can never be. You will only get like consecutive intervals. Rishabh says yes. Okay, cool. Cool. Now let's see the answer. Okay, like what I think the answer should be. Okay. Uh, okay. Let's say we had a node. Okay. We had a node. This is a node. And let's say this was a tree. Let's say this was a tree. Okay. Now, how many queries are needed through which we can identify any hidden node? Okay. Let's see for this one. My say is we only need 3 queries. Okay. One query for this one, for one query for this one, and one query for this one. The reason is because when we make a query from this one, the distance of this node. Okay, let me mark the distance of every node from this. This has a distance of 1, this has a distance of 2, this has a distance of 3, this has a distance of 3, this has a 4 distance, 4, 3, and 4. Okay. Now, if the distance of hidden node is 1, then we will be able to figure out that this is the hidden node. If it is 2, then we will be able to figure out that this is the hidden node. All these 6 nodes are left. How do we do them? Let's do the same thing from this node now. Okay. If we find the distance of all the other nodes from this node, the distance is 1. This has a distance of 1. This has a distance of 2. This has a this has a distance of 2. This has a distance of 3. This has a distance of 3. This has a distance of 4. This has a distance of 4. Okay. This also has a distance of 3, and this has a distance of 4. Okay. Now if you see, this is also uniquely identified. Okay. Now if you see, this one is for this only. Like the distance of this node from this is 1, and there is only one node which has a distance of 1 from this node. Therefore, we can uniquely identify this node as well. But we cannot uniquely identify this node, this node, this node, or this node, because again these are same only. There are two nodes with distance 3, and there are two nodes with distance 4. Okay. So what do we do? Let's make a query for this node. If you see, the distance is, this has a distance of 1, this again has a distance of 2, this has a distance of, okay, I'm not marking for these 5 because these are already done. This has a distance of 3, this has a distance of 4. Okay, this also has a distance of 3, and this also has a distance of 4. But since these are uniquely identified already, using this we can identify this and this as well, and this also, because this has a distance of 1 and this is already identified. So if you see, using these 3 nodes, we can actually identify any of the hidden nodes in this tree. Now, okay, let me make some changes to this graph. Okay, so the answer for this graph is 3 right now. Okay, what happens if we add another node? If we add another node, if we add this node also, then also the answer remains the same. The reason is because, let me explain the reason. Okay, so we knew that all the other nodes were uniquely identified. We only need to figure out for this node. Okay, now the distance of this node is what? 4 from this node, but the distance is 4 for this one also. So through this node we cannot uniquely identify. Similarly for this one we cannot identify, because again 4 and 4 distance only. But from this node, if you see, this node has a distance of 2, but this one has a distance of 4 again. So using this third node, you will be identified that this is the hidden node. Okay, is this clear? If it is like, if you're still not able to understand this, just go back into the video, look at this like again, and maybe then you'll be able to understand. Okay, cool. Now let's make some more changes. What happens if we add another node? Now if you see, you need to make another node as a query as well. The reason is because if you don't do that, there is no way to identify if the hidden node is this one or this one, because both of these have a distance of 2 from this node, and both of these have a distance of 4 from these two nodes. So there is no unique way of identifying which either of these two is the hidden node. But if you make any of these two as hidden node, then the distance of this hidden node from itself will be 0, and the distance of this hidden node from this node will be 2. And using that, you will be able to identify which either of these two is the hidden node. Okay, now again, like if you add another node here, again you won't have to make any special nodes. Okay, everything will be still distinguishable. Again, if you make another node, nothing happens. If you make another node here, then you will have to make this unique node, like a node through which you have to make query, because you need this special node to identify this one. Okay, cool. So I think like you are able to understand like how this is going, and the way I did was I find out all the nodes which are leaf nodes. Okay, so like this is a leaf node, so this is a leaf node, 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 this, and this is a leaf node. What I do is I try to find out like this node, the parent nodes of all the leaf nodes. So this node says that I have 3 leaf nodes. Since I have 3 leaf nodes, that means I need to make 2 of them as special. Similarly for this one also, this will say that I need to make 2 of these as special, and this will say that I need to make 1 out of these as special, because there are 2 nodes here. So 1 out of 2 these needs to be a special one. This will say that you need to make, since I only have 1 node, you need to make this as a special node. But if you see, since there is only 1 node left, okay, there is no need of making this as a special node, because right now in this graph you have this as a special node, 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 and this as a special node, and the distance of this node is unique from all these nodes. Okay, that's why, and that is pretty much my logic. For some reason it is giving me a wrong answer. I did look at Demoralizer's code, and it is pretty much the same code only. He just does a DFS instead of like doing it through degrees. But there is a slight difference, and like obviously that is the reason why I'm getting a wrong answer. But I don't understand the reason behind that. Okay, so yeah, if someone is able to like figure out the mistake in my code, they can let me know in the comments. I'll do check them out, and yeah, like if they can explain me like why it is not working. Okay, I think that's it. Let me look at the chart. Rating changes are out. Is that so? I think I had a plus delta. Let me see. Yeah, I have a delta of plus 50. 1770. Okay. Should I practice DSA because I am not able to solve C and D? Yeah, practicing DSA would help. Okay, but I think you can actually do A to OJ ladders as well, because since like I remember when I was stuck at problem C, I did problem ladder C of A to OJ, and I after that I was able to do C. Okay, became specialist today. Really nice, Priyanshu. Ayush says how to identify when to use DFS. I don't think there is a way, like there are some ways through which you can identify. You just practice and then like you get an intuition, or like you're able to see that you are actually able to like do this problem using DFS. Whenever you have to traverse the complete graph, there is a high probability that you'll have to do a DFS. If it's not a DFS, then if it's a BFS. Can they do? Okay, cool. I think that's it for the stream. Is there anything someone else wants to ask? Else I can end the stream. We do have a contest tomorrow as well. It's at 2:35 p.m. I think. Let me just reconfirm the time. Yeah, it's at 2:35 p.m. So, and it's a 2-hour contest. So I'll come live at 5 p.m. tomorrow, and let's see how many problems we are able to do. Okay. Try to be consistent, please, cause no one provides solution these days. Yeah, I try to be consistent, but like I have a really busy schedule nowadays, so that's why I'm not able to give frequent contests. I'll try to be consistent. You say is +1. Thanks. Okay, cool. Cool.